Hello, statistics students. Welcome to another video on measuring strength of association with correlation. In this video, we're going to look at the correlation coefficient in context. The correlation between the number of Google searches per day for zombie and vampire is R equal to 0.924. That's a really strong association. If we are told or already know that the association between these variables is linear, then we know that the trend is positive and strong. The fact that the correlation is close to 1 means there's not much scatter in the scatter plot. College admission offices sometimes reports correlations between students' scholastic aptitude test, the SAT, scores and their first year grade point averages, GPAs. If the association is linear and the correlation is high, this justifies using the SAT to make admissions decisions because a high correlation would indicate a strong association between SAT scores and academic performance. A positive correlation means that students who score above average on SAT tend to get above average grades. Conversely, those who score below average on the SAT tend to get below average grades. Note that we're careful to say tend to. This is a lot like when we did hypothesis testing and say we have sufficient evidence. In associations, we say it tends to. Because certainly some students with low SAT scores do very well, and some with high SAT scores struggle to pass their classes. The correlation coefficient does not tell us about individual students. It tells us about the overall trend. More context. Correlation does not mean causation. Some of the most important research questions in science, business, and government involve cause and effect. Quite often, we want to know if an intervention changes things. Does giving a patient a new medicine improve their condition? Does changing a tax law improve the economy? Does changing the placement of an advertisement on a web page cause more people to click on that ad? When two numerical variables are involved, the first step in deciding issues of causality is to make a scatter plot. Almost always, if there's a direct causal relationship, a scatter plot will show an association, although that association may be weak. And for this reason, a common statistical investigation question in these contexts is there an association? For example, participants in a study designed to determine if the type of diet affected the amount of weight loss. And they were asked a series of questions every month. These questions were designed to measure how well the participants followed their assigned diet. Researchers wondered if adhering to the diet caused weight loss. Figure 4.11 suggests that there is a weak but negative correlation between the amount of weight lost and the average adherence to the diet over the year. Subjects with greater adherence tended to lose more weight. However, one important step of the data cycle is that we consider the data, and in this context, that means considering how the data were collected. As we learned in Chapter 1, in an observational study such as this, the presence of potential confounding factors makes it impossible to conclude there is a cause and effect relationship based solely on an association between the variables. For the diet data, subjects determined their own level of adherence, and this might have been affected by other events in their lives, such as stress, that could have also affected their weight loss. For another, more fanciful example, consider this. A positive correlation exists between the number of blankets sold in Canada per week and the number of brush fires in Australia per week. Are brush fires in Australia caused by cold Canadians? Probably not. The correlation is likely to be the result of weather. When it is winter in Canada, people buy blankets. When it is winter in Canada, it's summer in Australia, which is located in the southern hemisphere, and the summer is brush fire season. If you learn nothing else from this book, remember this: no matter how tempting, do not conclude that a cause and effect relationship between two variables exists just because there is a correlation. No matter how close to +1 or -1 that correlation might be. Always consider the method of data collection and ensure that the method supports your conclusion. Again, correlation alone or a strong association between numerical variables, it does not alone imply causation. We need to have an experimental design to be able to conclude causation. And this concludes this video on measuring strength of association with correlation, the correlation coefficient in context.